Hello dear students, welcome to lecture number 6. Today's discussional points or topics of the discussion. Resistance of system of resistors. Here we are learning resistance of system of resistors in which series combination and parallel combinations we are learning. Advantages and disadvantages of series and parallel combination respectively. Let's move on to the resistance of system of resistors. Here I broke the resistance of system of resistors into 4 groups. One is resistance, second part is resistor, third will be the system of resistors, and fourth is combination of resistors. Alright, now let's redefine the term called resistance. Resistance, as we already know that, it is the property of the conductor. By that, it opposes the flow of electric current or to resist the electric current. By Ohm's law, it can be written as R is equal to V by I. Now, resistor, the device that opposes or resists the electric current in the conductor is known as resistor. The material or the device which opposes the electric current in the conductor or restricts the electric current in the conductor is known as resistor. Keep in mind, resistance is the phenomenon or property. Resistor is the instrument or device. Now, system of resistors. The number of resistors connected in groups according to the need is known as system of resistors. System of resistors means the number of resistors connected in groups. The number of resistors connected in groups as per our need, that is known as system of resistors. Now let's move on to the interesting part called combination of resistors. So we have two different combinations here. One is the series and other one is the parallel. The details of the combinations are going to study in the later part. So let's see how we are connecting the series combination of resistors and parallel combination of resistors first. So by that it is easy to move ahead. I am considering 3 resistors. So this is resistor number 1. This is resistor number 2. And this is resistor number 3. Generally, resistors are having 2 ends. Therefore, I am assigning the end 1 and 2 for R1 as well as R2 and R3 respectively. Now, how you are connecting the series combination? So, second end of first resistor is connected to the first end of second resistor. See, the second end of first resistor is connected to the first end of second resistor. Similarly, second end of second resistor is connected to the first end of third resistor. So, it is of the pattern 2, 1, 2, 1. So, this is known as series combination of resistances. This is known as series combination of resistances. So you are measuring the effective or resultant resistance across the ends named as A, B. That is the effective resistance of the combination, which we are going to derive shortly. So that is for series combination. Generally it is abbreviated as RS, the series resistance. Now for parallel combination, again we are taking 3 resistors. So we are naming it as R1, R2, R3, again, and 1 and 2, 1 and 2, 1 and 2 respectively. If you are connecting the parallel combination, take care of first end of first resistor must go to the first end of second resistor, and second end of first resistor goes to first end of third resistor. Similarly, second end of first resistor goes to second end of second resistor and second end of third resistor respectively. So this combination is known as parallel combination. So we are assigning the points here A, B. Diagrammatically we are following like this to see them in systematic order. In practically you can connect wherever you want, from these two ends or these two ends or these two ends. The choices are there, you are allowed to make that connection. So across A and B you are having the effective resistance RP. I am taking it as parallel resistance, that's why the naming RP. I hope you are understood the connections of series and parallel combinations in a simple manner. Let's move on to methods of connecting the resistors. Resistors can be connected in various ways, but the important are series combination and parallel combination. Series and parallel combinations are the basics of various combinations present. Let's move on to series combination of resistances and finding the effective resistance or combined resistance of 3 resistors connected in series in later part. So to understand series combination of resistances, if you want to calculate the effective resistance of such combination, the law of combination of resistances in series being used. So it states that the combined resistance of any resistances or resistors, the combined resistance of any resistors you may take connected in series. Remember, if you are connecting any number of resistors connecting in series, that is equal to the sum of individual resistances. That is equal to sum of individual resistances. Means combined resistance of all the resistors, which will be equal to sum of the individual or each resistances or resistors. So if R1, R2, R3 up to Rn are the number of resistances, then according to the law, the series resistance or combined or effective resistance is equal to Rs, which is equal to R1 individually, R2 individually, R3 individually, so on up to Rn. They are added. Okay. So here 2 points must and should you have to remember. Number 1, that is in this combination, the sum of potential difference across individual resistances is equal to the potential difference across the battery applied. Means here in each resistance or each resistor, potential difference varies, but it is equal to the sum of the all resistances. Okay. Now second one, the current is flowing through each resistances remains same. Means the current through whatever the resistor may be, it is remains same till the end. Okay. Means here potential difference or voltage is going to vary in each resistances, but that is equal to what? The total voltage applied to the battery. and the current in that remains same. Wherever you go for R1, R2, R3, the current across that remains same. That's what these two things mean to us. So these points you have to take care while deriving the next part. Okay. Now let's move on to calculating or finding the resultant or effective resistance across three resistors connected in series. As I already said you how to connect the series combination, as I said 2 1 2 1 regularly. So here I took three resistors R1, R2, R3. They are connected again 1 2 1 2 respectively. We have the combined end X and Y, and that X and Y is connected to battery through milliammeter or ammeter A through key, and that entire circuit is connected to, or sorry, that is also connected by the voltmeter V across X and Y. This combination, again you need to take care of these 2 points. Here the V1 is different, V2 is different, V3 is different, but it is equal to the sum across these two you have to remember. Similarly, the current I remains same through R1, R2, R3. You write that the potential difference across R1 is V1, potential difference across R2 is V2, across R3 is V3. Then the total potential difference across X and Y, that is equal to V equals to the sum of V1, V2, V3 respectively. Call that equation number 1. If Rs being the total resistance, if Rs is the total resistance across X and Y, and I with the total current flowing through that, then according to the Ohm's law, it can be written as Rs equal to V by I, therefore V is equal to Rs into I. I used the term Rs because to say the series resistance, this subscript S indicates that series resistance. Since I is same in all resistors, therefore it can be written as the current across R1, R2, R3. Therefore V1 is equal to R1 into I, V2 is equal to R2 into I, and all that whole as equation 3. So from equations 2 and 3, you are having V equation is equal to this much, and V1, V2, V3 values here. Therefore it can be combined with equation number 1. So we have V, V2, V1, V2, V3 respectively. Substitute all those. You left out with Rs into I equal to R1I plus R2I plus R3I. Then take I common. Rs into I, which is equal to I common R1 plus R2 plus R3. By that you can cancel I on the LHS and RHS term, that is Rs equal to R1 plus R2 plus R3. So the series resistance or the resultant or effective resistance of three resistors connected in series is equal to the individual resistances. So that holds the law of combination of resistances connected in series. Next will be the parallel combination of resistances. So parallel combination of resistances is also having the law, that is the law of combination of resistances in parallel. So according to that law, the reciprocal of combined resistance of number of resistances, the combined resistance of all the resistors connected in parallel, which is equal to sum of reciprocals of all individual resistors. It is equal to sum of reciprocals of all individual resistances. If you are considering R1, R2, R3, R4, R5, so on up to Rn connected in parallel, then according to the law, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3, so on up to 1 by Rn. The sum of reciprocals of these is equal to what? The combined resistance, that is the reciprocal of combined resistance. Now here we are also having the points to remember. In this combination, the potential difference across each resistance is same. The potential difference remains same in this combination. Next, the sum of currents flowing through all resistances is equal to the total current flowing. Means if you are having the resistances R1, R2, R3, current is going to distribute as I1, I2, I3 respectively. That's what it means. This is very simple. The potential difference in this combination is same as the total, whereas the current across different resistors varies accordingly. That's what the points needed to remember. Now we are calculating the resultant or effective resistance of three resistors connected in parallel. So R1, R2, R3 connected in parallel. So let's verify. One end is connected to one end connected to one. Similarly 2 to 2, 2 to 2 respectively. So we are having the 2 points, they are common to the all resistors. Therefore I am taking it as X and Y resistor, and also through the emitter A to the battery T respectively. This is how the circuit arrangement is there in parallel combination. Now suppose the current flowing through the resistor R1 is I1, through the resistor R2 is I2, R3 is I3. Let's assume according to the, not assume, assumption, that is as per the law. So I is equal to I1 plus I2 plus I3. That is the total current. The total current across X and Y, which is equal to what? I is equal to I1 plus I2 plus I3. So the combination is RP. The overall combination across that is taken as RP, the parallel resistance. Then by Ohm's law, I is equal to V by RP. It can be written as R is equal to V by I. Therefore, I is equal to V by R, the subscript P being used for parallel. Therefore, I is equal to V by RP. Call this as equation number 2. Since the potential difference V is same across all R1, R2, R3 respectively, then current can be written as, for I1 it is given by V by R1, for I2 V by R2, for I3 that is V by R3. So call this group as equation number 3. So from equations 2 and 3, substitute it into equation 1, this value into here, and these values in this combination results in V by Rp is equal to V by R1 plus V. I am just rearranging the things. So V by Rp as 1 by Rp into V, and I am taking V as common. I am taking V as common. 1 by R1 plus 1 by R2, 1 by R3 left out with after taking the common. This V and the LHS V are going to cancel. Therefore, you left out with 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equation which holds good as per this law. Okay. In general, you are writing like this. For 3 resistances, you are only taken with the first 3 parts of the resistance. So, I hope you understood the parallel combination right. Let's move on to the last part of the today's lecture, that is advantages and disadvantages of series and parallel combinations. The advantages of series combination. This combination is easy to learn and easy to make. This combination is easy to make and easy to learn. They do not overheat. They will not overheat. So heat is maintained in this combination. We can add more power devices to this. You can add more power device to get the more number of voltage. It reduces current sources. Remember, in this combination current is same. Therefore, it reduces the number of current sources generally. So these are all the advantages of series combination. Disadvantages: if one of the combination breaks, in this case, it breaks everything. It breaks everything means one. Say there are 5 number of voltage sources connected in series. If one is having problem, then it affects the rest 4. That's what it means. As the number of power sources are added to that, if you are adding so many number of power sources, it is every probability of getting the higher amount of resistance. So these are all the disadvantages of series combination. Let us move on to the parallel combination advantages and disadvantages. So in parallel combination, the appliances or material gets complete voltage. Unlike in series combination, it is not there. In each appliance, you are getting the full amount of voltage. In this, second one, if one of the combination breaks, assume if one of the combination in this case is breaks, rests are unaffected. Okay, in series it is affective. In this case, that is unaffected. Okay, in this combination, appliance gets proper current. In this combination, the appliance gets the proper amount of current depending on the resistance. And again, this combination easy to connect and easy to disconnect, but it's not so easy as series combination. It will take some time to learn. That's why it is easy to connect and easy to disconnect. Connection and disconnections are easy, but understanding will take some time. Disadvantage: lots of wires required. In this combination, to form this combination, one requires so many number of wires. In the other case, it did not. Okay, so you cannot decrease or increase the voltage here. You cannot decrease or increase the voltage, because in this case voltage remains same, current is distributing. Therefore, you cannot decrease or increase the voltage in this case. I hope you understand all the points whatever taught today.